Right. Today we are going to do response matrix. Uh, Let me first quickly open the VS Code. There are folders. Sparse, not the folder, no, CPP file. So, sparse matrix. What is sparse matrix first? We need to, first of all, understand that thing. So, first, let's open the page and I will try to explain you what is sparse matrix. Okay. So, let's say we have, matrix that is 0, 0, 0, 1, 0. This is the first row, and then 0, 0, 0, 0, stop, and then 0, 0, 3, 0, 0, and then 0, 4, 0, 0, 0, something like this. If we have a matrix like this, then you can see there are a lot of zeros inside of this matrix. So if we try to put this matrix inside of our storage, that is, if we allocate all of the elements inside of our storage, then it will take a lot of memory. Okay. So in this case, it is not so much, but in other cases where there is a very high or large order of matrix, then it will take storage, a lot of storage, right? So we don't need that thing. Okay, so what do we do now? So we use a trick that is we do not allocate the memory for these zeros. Okay, so we do not allocate the memories for these zeros. We simply only store the non-zeros value in our matrix. Okay, so we have a triplet form of for doing that. Okay, so let me show you quickly that what is triplet form. Something like this, and you will have row index here. You will have volume index here, and the value will be here. Okay, VAL value. Okay, so you will pick up the non-zeros values and find their index. Okay, so you will pick up the non-zeros values and find their index, and you will put that index into this volumes. Okay, this volume is known as triplet volume, that is triplet vector, something like that. So we will represent those non-zero values into triplet form first, and then using this triplet form, which contains only the non-zero values, then we can use this to do any calculation. Okay, any matrix calculation we can say. For example, we can do transpose of the matrix and store in without even converting it into the real matrix. So we can directly do the vector transpose, matrix transpose, and still in sleep. Oh my god. So we can do direct matrix transpose using this sparse matrix. And we can do calculations like addition, subtraction inside the sparse matrix by using directly from the sparse matrix. Okay. And then we can also do the multiplication between two matrices using its sparse matrix. So first of all, let's represent this element into this triplet form. So this is what is the index of this row index? 0, 1, 2, 3. That is 3. And column index, that is, uh, sorry, that was column index. The row index is 0, column index is 3. So the value is 1, something like this. Okay, so we will represent every element in this way. Okay, so I think I should use this. Okay, so I will place this letter here and 0, and the column is 3, and the value is 1. I will press enter, and then for the second non-zero value, that is 2, this one. So it has row number 1, 1, and then column is, I think, 0, 1, 2, 3, 4, 4, and then value is 2. And then next one is 3, that has row number 2, and then column number, it has column number also 2, and the value is 3. Okay. And then 0, 1, 2, 3, row number 3, and then column number is 1, the value is 4. So this is the triplet form representation of sparse matrix. Okay, so this matrix is known as sparse matrix. So we will store the element this way. This is our new matrix, which is known as the sparse matrix. So it is in row measure form. Okay, so row measure means the row is in ascending order, you can see, but column is random. If we make this column in ascending order, like this one will come first, and then this second, this third, and this fourth, 1, 2, 3, 4, like this in sorting order, sorted order. If we do sorting in column, and likewise the row and value also changes, so that will be known as the column measure order. Okay, so let's now use this row measure order, and let's just create a matrix. We'll input this kind of matrix. Okay, user will input this kind of matrix, and we will convert that matrix into this on this kind of triplet form. Okay, uh, okay, some this kind of triplet form. So we will not show this row column and value. We will directly show from here. Okay, so only this. So we will create a matrix that is 2D array and store these things, these index values of row and column, and then the value inside of that that index. Okay, so we will do that first, and then okay, we will create an array and store these values, and then we have to do what? Then we have to um, show that sparse matrix. Okay, print that sparse matrix. So first of all, I will need to write. Let me just write this. First of all, let me just take input from the user that what would be the size of the inputted array. Okay, so int m comma n, that would be the size order of the matrix that user is inputting. Okay, see out enter the size of the array. Then we have to include this great std. Okay, then I can take C in, and inside of this C in, so I take M, and again C in, and okay, I took the input of the order of the matrix. Now I will tell the user to enter the elements of the area or matrix. Okay, so and then uh, I will have to use loop with I equals 0, I less than M, right? And then increment for int j equals 0, j less than n, and n plus plus, right? So inside of this, we will give input, and we will equal this input inside of our array. So I haven't created my array. So my array will have the name of int and capital A, okay? Uh, and, and will be the dimension of this array. So inside of A, I, J. So I will take input inside of this, and the input will be now. I have taken input. Now I have to show this input. Okay. Let me just simply copy this and paste. Control C and then Control V, and I will remove this one, and I will key C out. Enter directly the matrix. That is way of I J. Okay. And after each outside of this loop, I have to change the line. Okay. Okay. And now, so I have taken the input from the user and displayed the input. Let me just check it by running. Size of the array will be my 3, comma 3, and the elements of the array I want to give 0, 0, 1, 1, 0. Sorry. 0, 0, and then 0, 0, 1, 0. Okay, what is happening, bro? Yes, and plus plus, bro, J plus plus. Okay. Oh no, I was doing M plus plus, N plus plus. What is this, bro? I was doing the wrong increment. Okay, so now let's check again. So the size of the array. The 3 into 3 elements. 0, 1, 0, 0, 0, 1, 1, 0, 0. Okay. 0, 1, 0, 0, 0, 1, 1, 0, 0. Okay. So this much is done. I think I should also include little space here. Backslash B. Okay. I think I should give this new line before of this loop. Okay. So fine. Now we have to think how to change our matrix into this triplet form. Okay, so for that, first of all, we need to compare each element of the matrix, if it is zero or not. So if it is zero, then we will, first of all, we need to find the dimension of the matrix by comparing if it is zero or not. So to know that which dimension of this triplet matrix we have to create. Okay, so first of all, we need to find the dimension, then we will create the matrix, and then again we will check for which indexes we have non-zero values, and we will directly store those indexes into the created matrix. Okay, we just created. So first of all, I need to write. I need to first of all I equals 0. I have to run a loop m I plus plus. Okay, this was the mistake I was doing. I don't know how did I write m plus plus and z plus plus. If I was doing increment in m and n, then it would be the infinite loop. Okay, again wrote I here. It should be j. Okay. So here I have to compare each of the elements. So if my all of the elements equal to 0, equal to 0, then mm, then what should I do? Then first of all, let me just make some variable that will count how many zeros are there and how many non-zeros are there. Int non-zero equal to 0. So I just declare two variables. So inside of this, I will do increment for zeros. Else I will do increment for non-zeros. Okay, so this is what uh, here. So I will copy this loop. Oh, sorry. I will copy this loop and I will paste it here because now what do we need to do? We need to create one array uh, to store those non-zeros element. Okay, so we will call it S. Let's say it S1 because we will be creating one more, and the dimension of this S1 will be non-zeros. Okay, non-zeros into 3. So let me make you understand this one. So the values one row, you can see here one row is wholly taken by only one element. So this row is for this one. This row is for this two. This row is for this three. This row is for this element four. Okay. So you can see one non-zero element is taking whole row. So the number of rows will be equal to the number of non-zero elements. So I have just written that thing. So non-zero element will be the number of rows. Okay. And then and the column will be three columns. We are representing in triplet form. So column will be three, obviously. So data type as well. In of this. And now if the value is zero, then I will have to write what? S1 of I j must be equal to I. Not I j, let's say I zero. right? And then S1 of S1 of I1 will be J, not J. Mm, yes, it will be J. And then 0001 and 02. Now we need to store our value. That is Ij will be what? Our value. That is A of Ij. Yes, okay. This is the thing. If it is zero, this should be for if it is non-zero. If it is non-zero, then the index inside of this 00 of our sparse matrix will be store the row index, and then next will be column index, and then this will be the value. But I think for this, if it is zero, then what should we do here? Nothing. Nothing. So how do we write nothing here? I don't know. Let's just leave it. Hmm, I should have created this like. I think I should have created it like this way instead. It's not equal to zero. If it is not equal to zero, then we will do this. So now we have also created our sparse matrix. Now we have to show the sparse matrix. So let's see if it is created or not. Int I equals zero. I less than the rows, number of rows is mm, what was non-zeros. That is the number of rows. And then I was for increase. And then for int j equals zero, j will be less than 3 because number of column is 3 for the triplet form. And then here I will be printing the out my values. That will be S1 of IA, right? Something like this. So I will include this thing here as well. Where is that? Okay, new line. Oh, I will add new line here, and let's see if it works or not. Size of the array, that will be 3, 3 comma 3, and then elements 0, 0, 1, 0, 1, and then 0, and 1, 0, 0. Positions are right, but values are wrong. Why? Sorry, I think this was a mistake. 3, 3, 0, 1, 0, 0, 0, 1, 1, 0, 0. Okay, now 1. Okay, now I think. Hmm. Yes, I think now it's good. But why are we getting like this? It's because of this end of line. I think so. Let's just remove this two. And then execute negative 0, 1, 0, 0, 0, 1, 1, 0, 0. Okay, now it's good. Mm, mm, okay, perfect. 3, 3, 0, 1, 0, 0, 0, 1, 1, 0, 0. Okay, now it's fine. You can see. Mm, mm, okay, why not something like here? 3, 3, 0, 1, 0, 0, 0, 1, and then 1, 0, 0. Okay, I think now it's fine. We have 0 and 1, 0 and 1, and the value is 1. This element has the index positions of 1, 2, 1, 2, and the value is 1. This has 0, 1, 2, 0, 2, 0, and value is 1. Okay, it's working. Okay, it's working fine. Now, so our sparse matrix, representation of the sparse matrix is finished. Now we have to do what? We have to do some operations. So, what we do what? We will do operations. I think we should do it just here. We will use these very matrices to do the operations. So operations, what we will do the operations? Mm, we will be doing, we will be doing transpose, addition, and multiplication. Okay. So let's just do the transpose first. So to do the transpose, let me just explain first what is the transpose of the matrix. So the transpose of this matrix will be we have to interchange the rows and columns of the matrix. Okay, so that's the basic thing. We have to interchange the rows and columns. So its column will become my rows and the rows will become my column. Okay, so zero, zero, zero. How many zeros are there? So just four. Okay, zero, 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 and four. Zero, zero, three, zero, 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 three, zero. Right, and then one, zero, 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 one, and triple zero. Okay, and then zero two and double zero, zero two and double zero. Okay, so this is the transpose matrix of this one. Okay, so if I represent this in the triplet form, then row measure condition it will be very different than this one. Okay, so basically what we are going to do is we are going to just swap this rows and columns values. Okay, so we will swap these rows and columns values. So that will do what? That will create that will do just simply represent a transpose matrix, but it will be in column, but it will be in column measure form. Okay, so it will be in column measure form. So we need to do what? We need to convert the column measure form into row measure form. Okay. If we do that, then we will get a matrix that is already transpose matrix, and in the form of row measure, triplet form. Okay. So let's write the code for transpose. So what we are going to do, we are going to swap the values. That means we will be uh, we will be using loop inside of our non-zero, non what what was the name of that thing? Non-zeros. That's a non. Why am I not getting that thing? This is non-zeros. I don't know. It's not getting highlighted. Okay, I'm writing outside of this. I need to go inside of my code because after return zero, the main function is finished. So this type of silly mistakes I usually do. And we are going to transpose, right? So we are going to transpose. That means we have to go through each of the line zero zero. So this one loop should be enough. Yes. First of all, we need to create another matrix, and we will be okay. So transpose matrix that will be S2. I will name it as S2. That is in S2 will be my non-zeros, non-zeros, non-zeros three. So that will be the order of my matrix, and then ouch. And then what is the order of my matrix? Okay, now I have to swap the rows and columns of my sparse matrix and input inside of this one. So I forgot to write two here. Okay, so I'll have to use m equals and mm, yes, m equals this one of I comma I zero. Let us declare the temp, in temp, and then I will have to write the s2 of I comma zero will be I comma zero will be s1 of swapping the thing. That means I comma zero will be I comma one, I comma one. Then then we use this thing. Then I comma one will be I comma zero. Okay. So this came here because I comma zero is already changed, and before changing it, we had assigned the value into 10. So now I think swapping is done, and now let's see by printing the thing. So see, we are going to print our new matrix that is S2. S2, okay. And this will work. And the size of the array is 3, comma 3, 0, 1, 0, 0, 0, 1, 1, 0, 0. So, so this we have already seen. This is the transpose one. Why the value is getting changed? Oh, value I haven't. I haven't inserted the value. Bro, value. Value is also necessary. So value will be the same. That is I comma 2 will have the same value as S1 of I comma 2. That is the this is capitalized. And now this will work. I think I should give a new line after this. See, now let's just see 3 comma 3, 0, 1, 0, 0, 0, 1, 1, 0, 0. Okay, now we can see the index values are swapped. So 0, 1 has become 1, 0, 1, 2 has become 2, 1, and 2, 0 has become 0, 2. Okay, and the values are same. So we wanted the values to be same as of the first is first matrix. So now, if you try to design a matrix by using these values, then you will get a transpose matrix. So let me show you quickly. 1, 0 has value 1. So you can see, mm, okay, 1, 0 has the value of 1. Let's see, 1, 0 has the value of 1, and then this is 3, 3, right? 0, 2 has value 1. 0, 2 has value 1. That means 0 and 1. And the 1, 0, 0. Then the last one is 2, 1 has the value of 1. The 1. That is 2, 2, 1 means this one. 2, 0, 1, 0. So this is it. So you can see 0, 0, 1, 1, 0, 0, 0, 1, 0. This is the transpose matrix. So let me show you the real one. So this was the matrix that we have inputted. Okay. So this was the real inputted one. You can see it is the transpose of this. Okay, this you can transpose this matrix and you will get this. So that is it. We have successfully generated a transpose matrix. But you can see it is in column measure form. You can see the sorting of the indexes is in column. Okay, so we need to change this into row measure form. So because we have one first matrix that is S1 in row measure form, and this S2 is in column measure form. So we cannot apply operations like we will apply some addition operations and subtraction operations further in the video. So we can apply in two different measure forms. So the measure forms will be same. So we need to convert the volume measure form, this one, into the row measure form. Okay. So for that, I have a code that will convert it into, I think, row measure form. Let me just try this one. I haven't tried this. This is my first try. And again, I'm writing outside of the return. Let me write from here. Some spaces. Mm, I will use one loop. Let's do a list. For I equals 0, I less than n, j. So j. That attack. Okay. Now we have used two loops, and one more loop we have to use int. Okay, we have already used L equals 0, and L will be less than our non-zeros, and then L plus plus. So three loops are there, and we will say if our value. Okay, we will check if I is equal to L S. Hmm. Okay, we will check for everyone. Yes. So what we are going to do is a simple thing. Yeah. So we are going to check 0, 0, 0, 1, 0, 2, 0, 2, 1, 0, 1, 1, 1, 2. So this will be given by my two for loops, right? So two for loop I and j will give me these values in each iteration. So I will get this type of values and I will compare this I and j. Okay, each of this I and j I will compare with these values. Okay, this is I, this is j. If it matches for any of these, then I will. So for this 0, 0, I will use for loop for all of these values. Okay, all of these matrix. For example, for this 0, 0, I will iterate over 0, 3, 1, 4, 2, 2, and 3, 1. And I will not find 0, 0, then I will go to 0, 1. 0, 1, 0, 1, 0, 1, 0. I will be finding by iterating over all of these rows of my sparse matrix. And 0, 2, 0, 2, 0, 2, there is no 0, 2. And again 1, 0, 1, 0, 1, 0, 1, 0, like this. So I will be iterating for every index position. And whichever I find, I will write that into a new matrix, which I will make here, that is row measure matrix. Row measure for transpose. Okay, this is for transpose. And it will also have non-zero, non-zero comma 3, the same order. If okay, if I equals s1 of I comma 0, s1 of no L comma 0. Okay, we are iterating over non-zeros every rows of my sparse matrix, so I will have to use L. So and then s of s1 of L1. I think it will work. Yes. Okay, for the this is comparison on the assignment. If this happens, if this condition is satisfied, that is I and j are same, are present inside of any of the row of my sparse matrix, then what I need to do, I need to push it, I need to insert it into my row measure matrix. So that will be, I need to first create one more variable that would be, since, yes, for that I have already created k equal to 0, and I will use this one now. So that is row measure array of, so it's k comma 0 will have, I will assign this k comma 0 as s1 of I comma 0. So I comma 0, okay. 0 comma 0, okay, and then 1 comma 0, so index is matched. So I is the index of row. So that's why I'm doing this one. Okay, I'll have to do the same thing here as well for one. And then again for values as well, I'll have to do the same thing. We are having 2 and here will be like here. And then for each when this condition is satisfied, it enters inside of this if condition, right? And it will update the values, insert the values, and then the value of k will be increased. Okay. So in the next iteration, this k will become 1, 0, 1, 1. So the new data will be inserted. So in the new row, that is fine. Yes, it's all good. Now I'll have to just see by printing if it works or not. If it doesn't work, then I don't think I can do anything at this moment because I haven't tried anything other than this. So I have just written this code and I haven't even done one single write. I'm just doing this on the spot. 0, 1, 1, 0, 0. Okay. Oh my god, nothing is happening. Oh, sorry. Sorry. I printed the same thing. Yeah, this is really. Okay. Now, okay. That is my 3, 3, 1, 0, 0. Um, I'm giving different input in each time. Okay, I think it is done. You can see the rows index is sorted. I think it is done. Okay, this code is working. Nice. Now I have a row measure S1 and row measure of transpose matrix. So I have two sparse matrix, that is S1 for original matrix in the sparse form, triplet form. And then for the transpose matrix, we also have sparse matrix in row measure, that is RM. Okay, so now we have to do what? So this is the transpose sparse matrix, okay, for row measure form. Yes. And I think I should keep one new line here to make it more clear. I think I should have just copied from here. Why did I go search of one? 3, 3, 0, 1, 0, 0, 0, 1, 1, 0, 0. Okay, you can see it is done. Nice. So now we will have to do addition. So transpose is done. We will be doing now the addition. So I haven't even tried the addition. So 0, 0, 1, 0, 1, 0, 1, 0, 1. So I will be inputting this matrix from now. Okay. So if I do addition of these two matrices, so I have the sparse matrix form of this one and this one right now. Okay. So this one I have stored inside S1 and this one I have stored inside RM. Okay, so I will need to do the addition of these two matrices. So addition will do give me what? So addition equal to I will get 0, 1, and then 1 again, and then I think it will be 1, and then 0 again, and then 1, and then 0, and 1, and then 0. So this will be the addition. Okay, so you can see if I make a sparse matrix from this, I will get what? I will get 0, 1, 1, 0, 1, 1, and then 0, 0, 2, 1, and then 1, 0, 1, and then 1, 2, 1, and then 2, 1, 2, 1, 1. So this is the sparse matrix for this addition. After we do addition, whatever matrix we get, the sparse matrix for that one is this. So we will be doing addition and we will be doing addition in the sparse matrix form, and this will be the answer. Okay, if I give input of this. So now let's try the addition. For addition, I think I have a code here written. Let me just look into this code. I don't know if this works or not. It should work. Int I equals 0, I is less than low, so it works non-zeros, I plus plus. Then again for int j equals 0, j is less than again non-zeros, and then j is also increment. And I will have one if condition here, s1 of I 0 will be if this is equal to s2. S2 means we have R inside of Rn of j0. If this happens, so that means mm, 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 right, 0, 0, 0. Okay, we are comparing the row values here. This happens for now. Electricity gone, bro. Electricity gone. What do I do now? Let me just try this. I can't see the keyboard. Okay, if this occurs, then we have to again check for the S1 pause. S1 pause my I comma 1. So I have to now check for the volume index. Okay, 0. That was now I will give this as 1 equal to Rm 1 underscore M of J1. J1. So again, if this condition is also matched, then we have to do the addition. So I hope you are understanding this. So we are doing what? We are comparing the indexes. So we are comparing the indexes. So I think I can tell from here more easily. This indexes. Oh, this even right or not? I'm now getting confused because I can see here that this sparse matrix and this sparse matrix are the same. This should have been in the first line, and this should be in the second line. This should have been in the third line. Oh no, the code is wrong. And I'm comparing with S1. I will have to compare with S2, bro. S2, right? Right, okay. So S2 stores the indexes and values for the transpose matrix in cool measure form. So I'll have to compare with that one. Always comparing with them. Okay. 0, 0, 1, 0, 1, 0, 1, 0, 0. Let me just see. Yes, 0, 2 is on the top. 1, 1 is on the second. 2, 0 is on the third. Okay. Now it is done. So code was not that wrong. Logic was not wrong, but code was wrong. So I put S1 here as well. That was the wrong. That was the mistake. Now let's just see here now. I think I'll have to continue other times maybe because I can't even see the keyboard and I can't even see my code here because I can't think the code whole code now because it's too much complicated. I think we have already crossed 100 lines of code. Oh my god, nice! But it's nothing. I don't think it's anything. I'm pausing the recording now. Okay, I will continue later.